Welcome to Lesson 2 on Factorial Notations and an Introduction to Permutations. So this lesson, we're going to talk about what a permutation actually is and how we can use something called Factorial, a new button on your calculator, to help us more quickly evaluate these expressions. So a permutation is just an arrangement of things where order matters, okay? So for an example, if I was choosing, let's say, a president, a vice president, and a secretary, where like there's three unique positions, that's a permutation because if you're the president, that's different than if you're the secretary. But if I was just selecting a committee of three people, where we all are just three people going to be on the committee, there's no specific jobs, then that's not a permutation, okay? So the permutation, we care about order. So you basically ask yourself, does order matter? And if the answer is yes, then it's a permutation. We're going to use the fundamental counting principle to kind of help us get going here. So it says you work in a daycare and you have 6 children in your group. You need to line up the group of children, determine the number of arrangements that the 6 children can form when they are lining up. So basically, I have to line up 6 kids. So I've got 6 spots. 1, 2, 3, 4, 5, 6. Remember, the fundamental counting principle is decide how many decisions have to be made and multiply the number of choices at each decision. So in the first spot, I could put 6 kids there. I have 6 to choose from. Once I place that one, there's 5 left, then 4, then 3, then 2, then 1. And when I multiply all of those together, I get 720 possible ways to line up the kids, which is kind of crazy, right? So doing it this way, it's okay for a relatively small number like 6, but what if I asked you to line up 37 people, let's just say, or 100 people? You probably don't want to be doing like 37 times 36 times 35 times 34 times 33. There's got to be a quicker way, right? So, and there is a quicker way, and it's called factorial notation. So what a factorial is it actually is represented by an exclamation point. So if you can find that button on your calculator, it might say exclamation or N exclamation. That's the factorial button. And what it is the product of descending natural numbers. So it's the counting numbers. Like you can't have negative numbers with factorial. You can't have any of those things. It's just the counting numbers, and it's the product of descending numbers. So 5 factorial would be 5 times 4 times 3 times 2 times 1. Okay, so if you want to find the factorial button on your calculator, we're going to evaluate a few expressions. So find that factorial button and try to evaluate 5 factorial. So 5 times 4 times 3 times 2 times 1, and you will see that it is 120. Okay, 10 factorial, so that would be 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Or we can just hit that 10 factorial button and we can see that it is 3,628,800. We can also do expressions like 5 factorial divided by 3 factorial. So you can put that in as 5 factorial divided by 3 factorial. I am going to just show you something though, because what this means is 5 times 4 times 3 times 2 times 1. And 3 factorial means 3 times 2 times 1. So technically we could cancel, and I would be left with 20. Okay, so sometimes these skills of being able to cancel things out, we're going to use those later on in the unit. So you should probably kind of understand what these mean instead of just getting locked into using the calculator all the time. Same thing for number 4. You could do 12 factorial divided by 9 factorial times 3 factorial. When I was kind of playing around with it, I did have to put the multiplication sign in between the two of them, and also make sure that you bracket your bottom if you're going to do it that way. I'm going to just go through though. So what this means is 12 times 11 times 10 times 9 factorial, because 9 times 8 times 7 times 6 times 5, right? The reason I'm leaving it like that is because then I have 9 factorial on the bottom times 3 factorial, which is 3 times 2 times 1. Now I left the 9 factorials because then those can be canceled away. And then when I look at the 3 times 2 times 1, well, 3 times 2 is 6, reduces with 12, so that gives me 2. So 2 times 11, which is 22, times 10 is 220. Okay, So I just wanted to go through that. You can for sure just punch it into your calculator and also get 220, but we're going to use this idea of canceling factorials later on. All right. Now, the number of permutations of n objects taken r at a time is represented with the notation NPR, and the formula is NPR is n factorial over n minus r factorial. So that might be if I have 6 people and I'm going to pick 2 of them to be the vice president and the president. Okay, so that would be 6p2. Okay, so find the value of 5p3. So we'll do it first of all with our formula. So this would be, oopsie, 5 factorial over 5 minus 3 factorial. So this is 5 factorial over 2 factorial. You can punch that into your calculator and it will give you 60. Okay, 18p6 would be 18 factorial over 18 minus 6 factorial. So that's 18 factorial over 12 factorial. You punch that into your calculator and it's going to give you, I'm just going to go down here because it's a big number, 13,366,080. Okay, so very large number of ways. Now, you also have an NPR button on your calculator, so I want you to take a minute and find that button. It's probably a second function. It'll look like NPR in all likelihood. You may have to look around for a little bit or ask me if you're unsure. It could be in a hidden menu, or it could just be a second function. Every calculator is a little bit differently, so if you need to pause the video and take a look, please do that. But we can use our calculator to determine the values given as of 12p10. So we can just use our calculator button to do that. And 12p10 is 239,500. Sorry, 239,500,800. And 8p8, oops, 40,000, not 43,000, 40,320. Okay, let's take a look at a couple of examples of actually using this now. It says, in how many ways could a gold, silver, and bronze medal be awarded in a race that has 6 finalists? Okay, so I'm choosing, I've got gold, silver, and bronze, so I have 3 positions that need to be awarded to 6 people. Now, it's different if you get gold than if you get bronze. So this is, in fact, a permutation. So, I mean, you can just use the fundamental counting principle if you really wanted to. You could go, I have 6 people who could possibly get gold, 5 then who could get silver, and 4 who could get bronze. Okay, or we can use our permutations. It's basically saying I have 6 people and I need to pick 3 of them. So 6p3. Either way, whichever one I use of that, it's going to give me 120. Okay, so it works the same both ways. How many 5-digit numbers can be formed by selecting different digits from the numbers 1, 2, 3, 4, whatever to 9, right? So there, if I'm going from the digits 1 to 9, that is 9 items I have to select from. Okay, they're different digits. So there's no repetition. That's important. And there's 9 to pick from, and I need to pick 5. Okay, so I can go 9p5. Again, you can fundamental counting principle like almost everything in this unit. So I've got a 5-digit number. I can have 9 things to choose from for that one, then 8, then 7, then 6, then 5. That's what it means. 9p5 gives me 15,120 different numbers that I can create. How many positive 3-digit integers can be written containing 3 different odd integers? I'm only choosing from the odd integers. So my set that I'm picking from is only 1, 3, 5, 7, and 9. So I have 5 digits to choose from, and I'm going to pick 3 of them. Okay, or if I'm doing the fundamental counting principle, it's 5 times 4 times 3 for my 3 choices, which gives me, whichever I use of those, 60. Okay, so I want you to go ahead and practice some of these questions now. We've got practice with the factorial, practice with the notation, and a few word problems for you to practice.